Now that we've figured out our addressing scheme and we've placed all our devices and we've configured our devices, it's time to practice seeing how what kind of response we can get from our devices. So first thing I'm going to do is I'm going to test to see if I can make PC1 do an echo request, a ping to his own gateway. So I just open up PC1 here, and the gateway is 33. So I'll go to desktop, command prompt, and this is a little bit small. I hope you can see it. Let's see if I can get this bigger. No. Ping 192.168.1.33, and you can see that I can ping my own gateway. So what that proves is that PC1 can ping this interface right here, the fast Ethernet interface on the router. Let's see if it can ping the 65 interface, which would be router 1's serial interface. All right, so we'll try that out. That'll be the next test. So I'll just do an up arrow, and I'll change that from 33 to 65. And you can ping the serial interface also of router 1. So that's good. So you can ping this interface and this interface. Now I'm going to try to ping router 2's serial interface, which would be 66. And this time what you're going to see is we're going to not be able to ping the we're not going to receive a reply from router 2, and the request times out. Okay, so unsuccessful ping. Now, why is that? Okay, so basically what we have is we have a situation where router 1 knows about two networks. It knows about the networks that are connected to its two interfaces. It knows about the network that's connected to its Ethernet interface, and it knows about the network that's connected to its serial interface. So when we ping each one of these interfaces, the router is able to return the ping because it knows these two networks, right? But as soon as we ping router 2 similarly knows about only the networks that are connected to its interfaces. So it knows about this network over here, and it knows about the network connected to the other router. But it does not know about this other LAN over here on the other side of router 1. It has no idea that this network exists. So it receives an echo request from PC1, and it says, I don't know where the 32 network is. I don't know where the 192.168.1.32/27 network is. And since router 2 does not know where the network is, and router 2 does not have a default gateway or a default route or a gateway of last resort, router 2 drops the packet, and we never get a reply from router 2. Our ping, our request, makes it all the way to router 2, but router 2, once it has the request, does not know how to reply, does not know about our network, and has not been instructed on how to do so. So if we want to make that work, we need to configure these routers and let the routers know, how do I reply in a situation like that? So to make this work, basically what we have to do is we have to let router 2 know about our network. So we'll go into router 2 right here. Okay, and what we're going to do is I'll do it first through this through this GUI setting tool. So we'll go to routing here, and we'll go to static routes, and we'll add a static route. So we'll say we're going to add a route to the 192.168.1.32 network. It's going to have a 255.255.255.224 subnet mask, and then we have to give it the next hop IP address on how to get there. And so for router 2, the next hop IP address will be router 1's serial interface. So we say 192.168.1.65. So to get to the 32 network, go to 65, which would be router 1's serial interface. And we click add, and now we've added a static route to our routing table. And then in the iOS commands shows the IP route right here. So now we should be able to return that ping. So let's see here. Also, I'm going to go back to global settings here and NVRAM, and I'm going to hit startup NVRAM, which is where our configuration is located and hit save. And now if I go to PC1 and I open up a command prompt and I try that same command again, you'll see that I get replies. Alright, and now what I can do is I can open up this router and I can look at the command line interface, and I'll hit enable to get to privileged mode, and I'll say show IP route, which will show us our routing table. And in our routing table you can see that router 2 knows about 3 networks. One is a static network that it's been configured for the 32 network, and then it knows about the 2 connected networks at 64 and 96. And those 2 networks are connected. So now, if I wanted to ping all the way across to this other PC, all I have to do is tell router 1 how to get to this network that it doesn't know about. Router 1 knows about this network and this network, it doesn't know about this other network over here. So I open up router 1, and I'm going to set a static route to the 192.168.1.96 network. The 224. The next hop will be '66. I'll add this route using this graphic tool. In the future we're going to be using the command line interface to do all this, but I thought this would be an easy way to get it started. And then I'll go to settings and I'll NVRAM, which is the memory where the configuration is saved, I'll save that. And then sure enough, now if I go to PC1 and try to ping all the way over to PC2, I'm going to change the name of this to PC2, you'll see that it works. So I'll go to PC1 here and I'll send a ping all the way over to 98, and it should work. And it's not working. Oh, there it is. There's a reply. You see the first one timed out, but then I got 3 replies, and now if I was to do it again, you'll see that I'm getting replies, and now I can ping all the way from one side to the other. If I went to PC2 and I tried to ping PC1, it would also work because we've configured static routes for these routers, and they know how to route packets to networks that they don't know about. Just this network here that doesn't know about, and this network here that router 1 doesn't know about.